open up your Spider again, go File, New. You can file, save as kind of example 2. Or example 0.2. We'll just go example 2. Okay. So we're going to do some very pure Python here. So without all of the other modules that we have. If you want, you can copy this line in from the top. Import IPython as IP. Get magic. That just kind of clears it out, right? So we're going to import some basic Python modules. So before we imported NumPy, SciPy, those are add-ons to Python. They're not actually intrinsic in Python. So for example, there's a numpy.mean and a python.math.mean, right? So there's different ways to do the same thing, like depending on kind of what module you reach out to. So we're going to go import random as random, import sys, import sys as sys, and that's going to import like system function calls. And then we're going to go import OS as OS, and that's going to import some operating system function calls, right? And then in Python, the # makes a comment. Sometimes I have long comments, right? And so 3 strings will make a multi-line comment. Python does not differentiate between the single apostrophe quote and the triple quote. So this also works. Does that make sense? You can use 1 quote or 2 quotes. Actually, it's very helpful sometimes when you're kind of quoting out. Sometimes you have to like have cascading quotes. You can do singles and doubles. Again, you can do # 3% signs. This makes a section. It does absolutely nothing to the code. Nothing. It just looks cool, right? Maybe you just want to know what kind of section you're in. You can print. Everyone needs to print hello world, and you hit F5, and then you can get hello world to show up down here, right? You can print something. So I just printed a string. Maybe I actually want my quotes to show up, right? I want hello world in quotes. So I can go print double quote, single quote. We'll just go hi world. And now I'll actually print my quotes down here. So I can cascade quotes like that. All right, so print will return a string from anything it can. So I can go print string. It'll print a string. If I print 10, it will report a string out of a number 10. Now I can print a list, which we'll talk about here in a little bit. I have a square brackets and a 10, right? And so these square brackets will tell me that this is a list. And so it prints a string of 10 inside a list. That's what the square brackets tell me. I can print multiple things next to each other, but I have to separate them by a comma. So I can go print string, comma, the integer 10, comma, a list of 10, comma, 2. And then I can get string 10, 10, comma, 2, right? So I can continue to kind of print out whatever I want. I can also combine those into a string, actually. If you wanted to just print a solid string, you could make 2 strings, like string and string, and then just use a plus between them. We'll put a space there. And now it's really hard to tell, but it actually just prints out one string of string space 10. That is one string. Okay, Python only has a few arithmetic operations: addition, subtract, and multiplication, modulo, exponential, and floor division. So this will be kind of quickly astonishing to you, maybe, or probably not. So let's go I equals 5 plus 2. And that's going to give you, in my variable explorer, that's going to give me a 7, right? 5 plus 2 equals 7. That one's pretty simple. I equals 5 minus 2. Yeah, that's going to give you a 3. I equals 5 times 2. That one's pretty easy. That's going to give you a 10. Now we start to get into, well, I equals 5 divided by 2. That one's pretty easy. Gives you a 2.5 as a float. What you'll notice real quick is 5 times 2 returns an integer, int. And then I equals 5 divided by 2. Watch that integer type in the top right. It now becomes a float, 2.5. Because Python cannot, it will return an integer if it can, and will return a float if it has to. Matlab will always return what you, will pretty much just always return a float unless you tell it that you want an integer, right? Python, one way Python can be a bit more efficient, one way Matlab can be a bit more robust in terms of engineering problem solving. Okay, so the modulo yields the remainder of the division of the first argument. So we can go 5% to, so I equals 5% to, and then we get 1, because that's my remainder, not something that I use a lot. Okay, exponential. Who would like to go I equals 5 caret 2? That seems pretty good, but it actually throws you an error. It brings you a 7. I'm not even sure. In Python, exponential are double multiplication signs. I don't understand it either. Okay, like I don't have an answer for you. But 5 squared is 25. So bring it up with them. Someone told me once mathematically it's correct. Sure. If you say so. Floor division yields the quotient of the arguments with the floor function applied to the results. So you can go 5 plus / 2. Oh, wait. I equals 5 floor division of 2. Wait, okay. There's not supposed to be a plus there. It's just double slash. That makes more sense. And now I equals 2, right? So my floor division of 5 divided by 2 is 2. And that is the 7 operations of Python. Any questions on that one? That's all Python can do. Everything else you do is a function built on top.
So can you repeat what the percent and the last one did? The percent and the double division?
So the percent is a modulo, MOD, ULO, and yields the remainder of the division of the first argument by the second. gives you what's left. It's the only place I've ever seen it used is in job application interviews for people who are applying for like coding positions. And then the floor division yields the quotient of the argument with the floor function. So 5 divided by 2 is 2.5. The floor of that is 2. Kind of rounded down. Does that work? So there's an order of operations in Python. I would get around it by just using a lot of parentheses where needed. Kind of the same as everything. You can look up the order of operations. So variables have to start, or they can't start with a letter or a number, right? So I don't think you can have like 8 name equals Bob, syntax error. You can have name underscore 8 equals Bob. You can do that. But you can't, variables have to start with a letter. All right, so there's different types of data types in Python. And we will use the 7 main data types, right? So the first data type, I'm going to delete everything I have. And then we're going to talk about data types. So II is equal to 10. And that's going to give me, so just kind of watch the data type up here. II gives me an integer. FF is equal to 10 divided by 2. That's going to give me a float. And then BB is equal to false. And that's going to give me a Boolean, BOOL. TT is equal to 1, 2, 3, BB. And that gives me a tuple, and a tuple can combine integers and Booleans, right? I just put BB into a tuple, but I can't change anything in that tuple. Of course, SS is equal to a string, so maybe put your name there. Now we have a string. And now I often want to use a list. LL is equal to square brackets. We can go 1, 2, 3, BB. Now what's interesting is I can do, if I look over here, I can do LL of 0, 1, 2, 3, because I index at 3, gets me false. But I can do LL of 3 is equal to 4. And now I just reassign the last value of my string to a 4. If I try that for my tuple, it should not work. TT of 4. Oh, wait, no, TT, sorry. Round parentheses of 3. I think it's got to be square parentheses and 3. There we go. TT of square parentheses 3 gives me a false. But if I try to reset it to 4, tuple object does not support item assignment. It is unchangeable. The only thing you can do is copy it out of a tuple and run it back into something else, right? It is unchangeable. Okay, often we want to store a lot of data in structures, right? Because we want to maybe share data between applications or pass things around. And for that, we can do dictionaries. DD is equal to curly brackets. We're going to do a string. This is a key, colon, and then maybe II. And now in my dictionary, for key, I have a 10. And I can do a comma You don't have to kick it down to a new line, but I'm going to. And I'm going to say TT is equal to TT. Run it again, and now my dictionary has an integer and a tuple in it. So if I want to bind up maybe a name of a data, a name of a person who took a test, all of the data from that test, and a couple different arrays, a couple different structures, some of them in floating points, some of them in integers, I can put them all into a dictionary, and then I can store the dictionary or save the dictionary. So any questions on data types? Okay, everyone's favorite, we got to do a for loop, right? So for I in range of 0, 3, colon print, let's print we are on item number, we're going to go space %d, and that's going to allow me to space %I, and that should allow me to print out, yeah, we are on item 0, 1, 2. Now you'll notice it's from 0, which is where Python starts, right? We index at 0 to 3, not including 3. So it's 0, 1, 2, 3. Matlab starts at 1 and includes the last one, right? We don't do that. So we go 0, 2, 3, not including 3. Does that make sense? And so you get, we are on item 0, 1, 2. Pretty simple. We can do a while loop. X is equal to 1, while X is less than 100. And then I can go print. I'm just going to copy this line up from here. And then it will just print it out. Oh, wait. All right. We have a problem. We're not indexing up our 1, and our code is just going to run for infinity, right? So I need a way to stop it. I think Matlab is like Control-C. That doesn't work here. So I'm just kind of using up an infinite amount of computing resources. I can hit this little red box here, which will interrupt my kernel and just throw an issue into it. However, sometimes if the kernel is on, another task, that won't cut it. And so you can hit this little X here, and you can just close out of your console. Another thing you can do, let's say you want to run 2 codes at the same time, you can right-click, new console, right-click, new console, and each one of these is a separate iteration of Python. And so you can run different codes at different times. But yeah, so running the code like that will cause an issue, but I can go I or X plus, you can go X is equal to X plus 1. I have absolutely no problem with that. Oh wait, yeah, this needs to be X, sorry. There we go, 0 to 99. Other people like to do this, they say it's more pretty. X plus equal 1, kind of a shorthand, does the exact same thing. That comes over from C, back when we used to use a lot of kind of shorthand like that. So we can also do compound statements that break. So we can go for X in range 3. We can go if X is double equal to 1. Double equal means check if these are the same. So if X equals 1, then do what's in this command, and we're going to go break. Right, and so it would first check through, X is going to start at 0. That's what range 3 means. It just starts at 0. We just didn't explicitly put 0. It's going to go through that, x equals to 1 will be false, so it won't execute this. Goes through it again, x equals 1 equals true, and it does execute that. We can also do else statements. So let's do that. Let's go everyone's favorite code. Just stack up the else statements, the else statements, the if statements. Let's go I is equal to D. If I is equal to A, print, I need to get my indent or it won't pick it up. Print the variable is, I'm going to put all of that in a string. Sorry. Plus I. And then that gives me a nice code that I can just copy. So, but if it's not A, if, so it only comes here if the last if statement was not executed. If I is equal to B, we can print that one. And then we can just kind of walk this all the way down C to D. The variable is D. We can do A. The variable is A. We can do C. The variable is C. And when you finish that, you've written your first piece of artificial intelligence, right? You can ask the computer a question and it answers you. I don't know if I would put an AI expert on your resume yet, but I completely agree that that falls under the class of artificial intelligence.